Okay, I think we can get started. Good afternoon, everybody, for joining this distinguished webinar series hosted by School of Electrical Engineering and Computer Science at the University of North Dakota and jointly co-sponsored by IEEE Region 4 Industry Engagement Committee. And with me today is it's extreme honor to introduce Dr. Brij Singh, who is the Manager, External Relationships and Power Electronics Technical Fellow. The title for today's talk is actually The Value of Electrification in Heavy-Duty Vehicles. Dr. Singh is a Region 4 Manager, External Relationships and Power Electronics Fellow in John Deere, USA. He has earned degrees in electrical engineering from various engineering schools in India. In 1996, he joined the École de Technology Supérieure, University of Quebec, Montreal, Canada, as a postdoctoral fellow. In 1999, he joined Concordia University, Montreal, as a research fellow. In 2000, he joined the Department of EECS, Tulane University, New Orleans, USA, as an assistant professor. In 2007, he joined John Deere, where he is the Region 4 Manager, External Relationships. Dr. Singh has published over 97 research papers. He has been granted 35 US patents, 1 trade secret, and over a dozen pending patents. In Tulane, Dr. Singh has received 4 teaching awards. In John Deere, he has received 3 innovation and 1 collaboration awards. He is the winner of 2020 IEEE Power Electronics Emerging Technology Award. In Feb 2020, he was awarded the title of John Deere Technical Fellow in Power Electronics Engineering. That's a great honor. In June 2023, U.S. Department of Energy recognized Dr. Singh's outstanding contribution and insightful technical expertise by Distinguished Achievement Award. In 2020, Dr. Singh was elevated as an IEEE Fellow and lives with his family in West Fargo, North Dakota. Dr. Singh, it's an extreme honor to have you here as part of the webinar series at UND. Thank you so much for agreeing to do this talk, and the floor is yours.
Thank you, Dr. Klaus. So I will begin sharing my desktop. And thanks for having me, and thanks for attending this webinar. So I'll put in presentation mode. We tested it already about audio video quality. I assume I'm coming clear and you could see my desktop, right?
Yes,
presentation mode.
We are good.
Good. Yeah, so today I would be talking about the value of electrification in heavy-duty vehicle. John Deere has variety of vehicle, as you see in this screen. One vehicle looks very different from the other. So we are doing electrification for intentional reason, means if this deployment of this new technology is bringing the value to our customer, making them profitable, better job quality, sustainability, and also the greenhouse gas reduction means overall.
Dr. Singh, can I interrupt? I think there is some kind of black screen on your front, on the top. In the middle.
I can just minimize it, right?
The
this
middle,
one, right?
Yeah, that one. Yeah,
it's gone, right?
Yeah, it's gone. Yes, thank you.
Yep. Yeah. So basically the idea is that you want to reduce the overall carbon footprint, and electrification is one of the enabling technology. In addition to that, a variety of farming practices, including precision farming, that requires a lot of computational science like AI, machine learning, machine vision, perception, and things like that. So what I'm trying to say is that John Deere is a very high-tech technology company, and adding customer value to our customer who are owner of these vehicles and have farming operation, construction, mining operation, and turf care operations. So about myself, and I'll give the little bit background. My background is starting from India, Deere and Company, then some electrification program that I was involved, and then this silicon carbide inverter project was funded by Department of Energy, and then innovation we did and experience and some additional government funding recently I acquired to do advancement of technology, emerging technology, advanced technology, apply them, problem solving in John Deere. followed by some summary. So this is about me. So this is me, and I was born and brought up in India. So this is the, like in US equivalency would be like an upper Midwest, like in North Dakota, South Dakota, and like a Minnesota and all these regions. So I'm pretty much like upper Midwest area of the India. And then, this area is surrounded by two rivers, actually, River Ganga and Yamuna, and very, very fertile land. So like when I was growing up there, people take, only one or two crop per year. But now, last summer I was in India, it's 4 crop per year is very common. Now has become very common. So India has become surplus in grain production, except few grains. Otherwise, and also it's the most populous country in the world now, 1.4 billion people. So they have to be surplus in grain production. So why I'm sharing this slide, it is because when I joined Deere, one was very common theme. I have discussion whomever I met. Hey, I'm first generation kid in Deere, coming from the farming background. And it's similar to mine. Actually, I'm first generation, family member that gone 12 after high school education and coming from farming background. So mainly knowing your customer is very, very important for Deere and company. So people who came from farming background are really, really helpful to new product, new technology, solving really problem that our customer face day in, day out. And my people will pull the land record from the revenue office, and my family officially, like as per record, has farmed this land since 1360, and I'm sure they lived there more than that 1,000 year or maybe 1,000 year plus. So I'm very, very proud of my farming route. And then this is about knowing your product, like how your product are being used. And as a power trans engineer, you must understand importance of one of the stress that our product endure is actually the temperature and thermal cycling. So until I earned my PhD degree, I remained in northern India. In summer, it gets very, very warm. Fahrenheit, it gets about 123 degrees C, and dry heat, which is in degree C, actually it's about 50 plus degree C temperature. Then I came Montreal, where in winter it gets very, very cold, as cold as -40, maybe often -45 degree. Then I migrated to New Orleans, where it gets hot and humid and all that, and gets at 45 degrees C. And now I live in North Dakota, and even D is in North Dakota, as you know, that with wind chill and all that, it can get extremely cold, right? You may feel as cold as -50, -60. Well, not every day, but at least few days. So it's a question of experience, right? So every time I made a major move in my life, I endure what you call delta T. And that's exactly happens to electronics and powertronics, that when you apply the power, or when you force the computing machine to compute a lot of data, then temperature is goes up for chip and or for die and devices, right? Semiconductor devices. And that's what is detrimental to the health of power converter. So essentially, this is knowing the product and knowing myself and environment or product will survive has been extremely helpful for me to design and bring that know-how in product design and technology design. So Deere and Company is a very, very old company. I think it was founded 1837, so maybe about going, more than 275 years. And John Deere is world leader in providing advanced products and services, and is committed to the success of those linked to the land. And Mr. John Deere was Iron Smith. He passed on 4 core values to the company: integrity, quality, commitment, and innovation. And we use these 4 core values to conduct our business, whether we are interacting with our employees, our customer, our suppliers, or even out facing like places like our interaction with universities. So why electrification off-road equipment and vehicle is so important? it tied to the pretty much shortage of skilled labor workforce in across the world, actually, I would say. And also the carbon footprint story. Recently now, sustainability, you may have heard about overall carbon footprint reduction, less carbon intense business, our grain production system, our construction system, road building operation. And in addition to that, we added these three, like a pillars to conduct the electrification aspect of the business is precision, means how precisely you could complete a job and how you could save and can you pass on some economic value. It would be very obvious one of the video that I have how precisely you place the seed on the ground using power converter fed electric machine, and not only that, productivity of the vehicle is 3 times better than the state of art before that technology came out from Deere. Then productivity means for farming operation and even for construction, I would say the window is very narrow that you want to get done a lot of work in a given time with minimum resources needed and input cost. So productivity of these vehicle, putting software-enabled electronics, software-enabled power electronics in these vehicle has increased the productivity of our customer and vehicles. And then sustainability means, can you sustain the operation? Can you remain profitable year after year? And not only that, environmental sustainability. Can these technology help you reduce overall application of chemical in the crop, or can these help reduce overall the fossil fuel burn, or the overall, what you call efficiency, like a less fuel, less energy consumed for a given job. And then last but not least, shortage of skilled labor force. Farming is a very, very labor intensive operation. Unfortunately, it's like a seasonal work, right? So you need to get done some work and then there may not be much work for, remaining month of year. So it's very hard to attract labor for farming operations. So can you automate as many as function possible in the vehicle? And I was just talking to my farm manager, he's from North Dakota, and he said, Brij, I went to help my brother in somewhere northwest North Dakota, and all I did was he was doing tilling operation, and all he did, press the button, go straight, turn, press the button, go straight, and do nothing, right? So can you imagine how easy it can become on a farmer to operate these vehicles? And even somebody is not very trained with a lot of function automated in the vehicle, you can pretty much become a skill operator pretty quick. So this is a very, very important slide. What that is, basically, if you want to grow 1 acre corn, carbon intensity of that grain production, corn production, is actually like you have driven 4-seater car 2,500 miles. So grain production is extremely carbon intense, and it is coming from like application of chemical. The photosynthesis process, that's only one absorb the carbon and put into the ground and raise it. The soil quality means more carbon in the soil, better the soil health. But remaining operation that you see, tilling or application of nitrate or fertilizer, all that is actually carbon intensity. And this carbon CO2 equivalent actually has 3 gases there. One is CO2, another one methane, third one nitrogen oxide. So, and the environmental global warming, intensity of the nitrate is very, very high, actually 300 times more than the CO2, and methane so as, so all these 3 gases put together is causing that much, like a carbon footprint, right? CO2 equivalent. And agriculture alone is contributing 50 billion metric ton CO2 equivalent per year. So it's a lot of carbon intensity in grain production system. So can automation, can precision agriculture minimize overall carbon intensity? So that's what we are working on and applying new technology in our product. So I will play a video here. It is just about how precisely you are putting seed on the ground. And next slide, I will explain the importance of that precision work. You may be, are you hearing the sound?
We've continued to push the boundary.
Please confirm if you are not hearing, because it seems like, yeah, you should be hearing, sorry.
Yes, we have sound.
At John Deere, we've continued to push the boundaries so that we can offer growers as many profit-generating options as possible. But to get to that truly next level of performance, we took a giant leap to ensure that you get higher levels of yield and productivity. Let's take a closer look at what separates the game-changing ExactEmerge from other planter row units. As you can see, there's no seed tube. Know what else you don't see? Seed rolling in the trench. We replaced the seed tube with a new delivery cartridge, the heart of this revolutionary planter technology. Inside, you'll find the brush belt, which delivers seed directly into the trench on a dead drop, with no roll, at up to 10 miles per hour. Each seed is carried by the brush belt, but not before passing by our all-new seed sensor. Think of it as another set of eyes where you need them most. Population, singulation, spacing information. It's all gathered at the sensor. Every precious seed is carefully spaced and carefully placed. The new bowl-shaped disc singulates your seed, while the concave shape allows the brush to grab each one effortlessly. Watch how these paddles push seed into the center of the brush belt so you can feel confident knowing there's a secure handoff every time. And thanks to the improved brush style doubles eliminator, only one seed rests in each hole before the disc hands it over to the brush belt. This allows you to enjoy the highest possible singulation. Of course, this high-efficiency meter system wouldn't be complete without a superior vacuum. That ensures the disc holds the seed tightly before it's passed on. Check out the new hopper design that helps you get the most of your seed pool by maintaining target seed population on slopes of up to 15 degrees in any direction. But there's more. 2 independent electric motors keep ExactEmerge running smoothly. One that rotates the meter, the other turns the brush belt. This gives you the speed matching delivery and population only ExactEmerge can offer. Not enough? How about the fact we've made active pneumatic downforce standard on this planter? And when paired with the new brush belt delivery, you get optimal depth for maximum yield at 10 miles per hour. Just set the downforce margin you want and run confidently. It's that simple. Finally, a planter with no trade-off between speed and accuracy. A planter that buries the myth of only planting at 5 miles per hour. A planter that marries precise seed placement and productivity. It's the all-new ExactEmerge row unit from John Deere. Accurate at 10 miles per hour. Exactly.
So essentially what you saw here, that no matter what soil condition is, that you are precisely placing seed on the ground so that all the plants emerge above the ground at same time. So that's what we began calling this product name as ExactEmerge. And then whether there's a 15-degree grade, elevation, all that. And then it is like a 40 robots, so walking behind tractor at 10 miles per hour, and each robot is driven by GPS. So when you are turning, some of them are turning slower, some of them turning faster, so that you are making sure that the seed placement from seed to seed spacing and row to row spacing is actually constant, right? Not varying, whether you go 5 miles per hour, 10 miles per hour. So there's a science behind it that if seed placement is precise, then the grain production will go up by quite with percentage number. And if you plant it in right time, right? Because if you have 10,000 acre farm, how you can plant, right? You need to go 3-4 times faster. So this technology has allowed us. So another thing is that you remember that I was telling the story of carbon and carbon intensity in grain production. So this is actually dispensing the starter fertilizer called dosing. So what happens, each seed is seen by a camera, and then since the exact image planter is putting seed is right on the ground without rollover, so then you dispense very small amount of fertilizer. It's like when you go your eye exam and doctor puts the air in your eye and dilates, like to see the all the examination, exactly like that. So it's such a precise process that imagine that you are going 10 miles per hour, you're turning and slowing down, whatever, and then is still able to place the seed on the ground, and if still able to put very small amount of fertilizer. You could have fertilize entire row, right? Entire farrow, but that would be waste of fertilizer, and that may cause carbon intensity. So this is actually the value electrification, and those power converter fed electric machine are actually enabler. Before that, we were just somebody was our customer, or our previous product was about 3-4 miles per hour. This goes as high as 10 miles per hour. So some electrification example when I started in Deere and Company. So this is one loader that I work on. There's a YouTube video. I plan on not playing this, but the electronics that I designed for this may have seen close to 40 to 50 million field hour, because this loader accumulative, all the loader that we put in customer hand have seen 1 million accumulative hour, and there are 40 such circuits that I have designed for this product. So this is how we do reliability calculation, right? So 40 times 1 million, 40 million, and that was 2020 data. So by now, even it could have exceeded. And the good thing is that not a single failure. So as you know, Deere is known for product quality, right? So this one, without electrification, we would not be able to do it. So Deere has the largest engine size. Now they are making another larger one, like a 20-liter engine, but 13.8-liter engine, which is roughly 500 or so horsepower. Without that, if we did not do electrification, we would not be able to put together this vehicle. So there was a conventional vehicle that consumes 24-gallon diesel per hour while working, and this one consumes under 10 gallons. So there's about nearly 60% fuel saving when you begin to calculate, right? Like imagine that if you burn 1 liter diesel, it puts out, and depending upon if it's petroleum diesel or it's a biodiesel, like a ethanol mix, depending upon whatever it is, but it can put out as high as 12 kilogram carbon dioxide. So by cutting, from 24-gallon per hour diesel to under 10 gallon, we are cutting multi-million metric ton carbon footprint by electrification. So that's kind of a sustainability story. Another thing is that control has allowed us to cancel the tire spin, because these vehicles are used in quarry mining and over the ground, like not underground but over surface mining. And often in mining operation, road is not paved. Always there are some pointed object, and if tire spins, you can ruin the tire, and tire is very expensive. So this is nearly $1 million vehicle, like maybe costing about $900,000. Another beauty of this vehicle is that ground torque of this vehicle is 1 million Newton meter. So that is the thrust. You can imagine that if there was an aircraft of this size, it would fly such a high thrust, but it is made to basically do the things on the ground. And without powertrain, without electrification, we won't be able to do. So I was so blessed to contribute in this product development and launching of it. This is another product that I began working when I joined Deere. It's a 644 loader. Here we run engine at a constant speed, so as we run a 944 loader also. And then we produce electricity and then 3-speed transmission system, depending upon the operation, transport, or the dodging operation, stockpiling, or whatever. But what it is doing actually, it is replacing electrification, replacing traditional torque converter. It's like energy to power conversion. So let's say you are push this loader in a pile of the dirt or concrete, and you need a lot of power, right? But then at 0 speed, then the power doesn't exist. So you speed up the engine, slow, and then push the bucket in the pile. At that time, it is energy actually. So power to energy conversion type, that's called traditional torque converter or hydrostatic drive. So since engine is varying over a wide range, that's why these are very inefficient, But by adding electrification power converter fed electric machines, you run engine at a constant speed. And by doing so, we save the fuel, we downsize the engine, and all those benefits are there that customers are seeing. In addition to that, you can apply the power where it needed the most. So you can very quickly apply the hydraulic power to electric power type management or include power management technique, makes it very performing, very productive loader. Means in a given time, you can do more work. So I get to ask, okay, these are hybrid vehicle. What is the size of the battery? Answer is battery is only to crank the engine. Essentially what it is, that diesel engine spins at a nearly constant speed. It can vary, now and then, but usually as come to hydrostatic drive, nearly constant speed. Then you have gearbox, then you run generator at 3 times of engine speed, which is about 5,400 RPM. And then you produce electricity using power converter fed electric machine, like generator driven in voltage mode, and then traction system is driven into torque mode. And when you are slowing down, a couple of millisecond DC bus voltage can go higher than the designed value, then you burn that electricity into this power register. Actually, it's 150 kilowatt water cooled resistance, and you burn electricity. If you did not do that, we would not be able to control the vehicle. So essentially now, if we begin putting a battery, then we can absorb that energy. When we were designing this in 2007-8 timeframe, at that time, battery technology wasn't mature enough, cost wasn't down and all that. But now we can begin putting battery, and we began really calling them hybrid drive, right? So you have battery power, you have engine power, and you run engine at a constant speed, and peak power comes from the battery. So I would now talk about John Deere product in Power America. So when President Obama was in office, so he began establishing manufacturing innovation institute across the US. So Power America was the second institute. It was $140 million effort from US government funded by Department of Energy. And Deere is a founding member of Power America. So we drew quite a bit funding from Power America. And we developed very, very advanced inverter technology. Actually, my IEEE award, Emerging Tech Award, was based on this work I did for the company and for DOE. So we were given very, very aggressive goal in 2013 timeframe. Very, very high efficient inverter, lightweight, light, size, small size, and all that. And then also as compared to hydrostatic drive, this inverter should offer more than 25% fuel economy. And then another thing that we signed the objective was that because this wide band gap material, silicon carbide, gallium nitride, are high temperature material. These are new generation material. You can operate them high voltage, high temperature, high switching frequency, and silicon carbide has a high thermal conductivity. And then benign failure due to cosmic radiation is not that much as pronounced as it in silicon semiconductor. So you can really exploit all these unique properties that are absent in silicon semiconductor. So we wanted to exploit all of them. So that's why 115-degree number came from. And the idea is that if you have dedicated cooling system in the vehicle to cool the inverter, if you eliminate that, there's quite a bit saving. And not only that, there's a system integration benefits and all that. So this was quite advanced work then in off-road vehicle. Nobody was doing such a work at that time. So there's a risk. There are supply chain issues that must be understood. But if you overcome these barriers, then you could get competitive advantage. And how you could do by innovation. So you remember those four core value, innovation is one of them, right? So people like me, and there are many such engineers in the company, all continuously innovating new product, new technology. Where we end up after the conclusion of the project, we started in 2015 and 21 we graduated program. So we had very high power density goal, and we nearly doubled the power density. So very small size inverter. Next slide, you will see how smaller it became. And then the efficiency 97%, two-stage power take in the inverter, power out from the inverter, because there were two inverter package in the same box, more than 97% efficiency. And over the coolant, we proved that efficiency 98% and higher. One inverter alone is 99 point some percentage. So very high efficiency inverter technology. And then 2-3 generation development we did. A lot of innovation went on packaging, thermal management, and things like that. You will see there's a video on it. So imagine that when we ran, we increased the coolant temperature by 10 degree, and inverter was running 10 degree, about 20 degree lower temperature. And it is all about paying attention to basics like packaging, thermal management, and making sure you are not putting lot of thermal resistance from the semiconductor to the cooling system in the inverter. And no matter how good this technology is, that if it doesn't meet the cost target, it doesn't go anywhere. So our work, 5-year work, indicated that at system level we can design cost neutral and performance superior solution, and that led us to launch a production program. So in few years down the road, you will see silicon carbide inverter driven tractor in the market. So this is the inverter, that left box that you see. I began working when I joined Deere in 2007. And this is our Gen 2 silicon carbide inverter. This weigh about 70 kilogram, lot of materials used, right? So if you cut down 1 kilogram aluminum, 1 kilogram copper, you are setting aside, you are cutting off nearly 35 kilogram carbon footprint. So designing a smaller product, less material intense product is a good idea. This is a green product, I would call. And then also the capacitor size reduction. So we did a lot of, I know this class, maybe a lot of power system engineers are there, but you need to attack this problem from the control standpoint, packaging, thermal management, all that. And we exploit the unique property of silicon carbide and reduce the capacitor from this inverter 13,000 microfarad to as less as 440 microfarad. So even if devices are expensive, but if you take the system approach, you can get cost neutral, performance superior solution, and you can deploy such technology. All these are similar inverter. All of them are 400 kilowatt capable. They have electric braking, and we took advantage of modularity in these inverter. Remain like a left three boxes, right, starting from PD 400. PD stands for power drive. 400 stands for 400 ampere continuous current, switch at a 4 kilohertz or so. And so modularity means you pay down development cost once, and you can begin to deploy such a product across the vehicle. An idea is that Deere is not selling one model million vehicle per year as opposed to on-road vehicles, but you can use one component or one software across the vehicle, and that's what modularity is. So your development cost is spread across the product, which is good thing for industry. Then increasing power density gave us competitive advantage, means when we were taking these products to trade. So when we were doing this about 2010, 12, 11 time frame, moment this came out in 14 or so, they began asking this. When we began showing this one, aircraft customer were almost begging to us, could we have our hand on these? Since this wasn't very high TRL, which is technology readiness level, if we were at TRL 8, 9, probably we could have given, right? So we did not give anyone. We are developing a variant of this for production program. Decreasing size and weight, form factor gives easier integration. I toured once our loader factory in Devonport, Iowa, and the fact that vehicle can rotate to same manufacturing station over and over, that's adding the cost, manufacturing cost. So if you minimize the component size, that can help cut down the manufacturing steps, so it lowers your manufacturing cost, and you can get more, either you are more profitable or you are passing that saving to your customer, and you are more competitive. And improved performance and high temperature gave us system benefit, easier integration on system. So why off-road vehicle are so different? It is near zero speed requirement and stall torque. As you know, on-road vehicle, you accelerate and you go, right? Off-road vehicle, if you want to go from one point A to B, oftentimes you must hit something, right? You hit crop, you hit tree, you hit concrete. In on-road, you want to go point A to B without hitting anything, right? That's a very different paradigm, design paradigm. And then oftentimes you are operating near zero speed. And that is very, very taxing to the power electronics. Or design requirement as compared to on-road vehicle are quite different. So we need to be mindful about that and design product, how these are being used in field. So we did 3 generation of silicon carbide work. So when I got, as some of you may be acquiring government funding, getting government funding, I would say writing grant application, all that, not easy, but I would say easy process. Doing the work, doing the project is completely different, right? So when and difficult magnitude are difficulty. So when I had this funding, at that time we did not have any idea about what silicon carbide is all about, just book knowledge. So idea was that if you are working on some risky technology and you have risk of failure, then fail fast or experience fast and move on. So we did, gate drive design, we did capacitor design, all the in-house. We took our PD400 production inverter and pretty much retrofitted that with the silicon carbide module, capacitor. We also did some dV by dt filter, means making sure that motor fed from this inverter doesn't experience lot of transients, lot of voltage, sudden voltage swings and all that. That's detrimental to insulation, bearing current, and then things, common mode voltage, current issues and all that. But with no knowledge in this technology, within 10 months, we were spinning the electric machine with silicon carbide. So that's kind of like beauty, that if you are in technology development space, speed and scale is extremely important to be successful. Then we put our Gen 1 inverter, which is basically the its own in silicon carbide inverter, its own housing. Remember, our goal was 25 kilowatt per liter. We missed that goal, but we applied some of the like super low inductance bus bar, nice packaging, thermal management, and we qualified that indeed this can run with engine coolant and continuously operate at a 150 kilowatt power and 200 kilowatt peak power. And then in 2017, Deere management had quite a bit funding for me and team. Then we developed this module. So this is silicon carbide module developed by a company called GE Aviation System. It's a GE branch of aviation branch of the GE company, and develop the power module, eliminate a lot of voltage joint, integrate current sensor, eliminate a lot of manufacturing steps and all that. And not only that, power module became so small that we were able to put both inverter on same side. You saw those boxes, right? Sometime, both inverter are sandwiching the cold plate. In this case, it was different. So minimizing the inductance between generator and traction inverter helped us develop advanced control. And then we got and achieved our power density goal. So we trust data sheet, but we do qualify over the temperature. So we qualify each component from -45 degrees C to 105 degrees C ambient condition, and test qualify high current, high voltage, and then power current, power voltage. Means these current and voltage waveform that you see lower, waveform, these are going to be equivalent to if you are putting 200 kilowatt power in and power out. So after qualifying this module, then you build the inverter. So from like those $6 million plus quite a bit funding from Deere, nearly this project became $12+ million program, and then we gotten from here to here in 5 years. So it takes quite a bit of effort to get this thing done. So from 35 kilogram inverter to under 9 kilogram, much smaller footprint, lot less material, easy to put motor inverter together, and essentially we can even eliminate the cables in here. And that's one trend that I'm seeing in industry, that now people are putting inverter motor together in advanced cars, so that it's coming, and so at Deere is putting. So I think I have time, so I'll play this video. And this will talk about quite a bit innovation that was gone into our silicon carbide program.
Introducing the first of its kind, extremely power-dense, engine coolant capable silicon carbide inverter technology for the electrification of heavy-duty vehicles from John Deere Electronic Solutions and the National Renewable Energy Laboratory. The compact, market-ready Expect technology offers high efficiency and high performance power at the extreme temperatures required of heavy-duty construction, mining, agriculture vehicles, and on-highway trucks and buses. The market-ready Expect silicon carbide technology can enable companies to meet emissions guidelines without sacrificing vehicle reliability. Key achievements in the design of the Expect technology enable a higher power density of 43 kilowatts per liter alongside advanced circuit protection and thermal management for coolant temperatures up to 115 degrees Celsius. The converter system also has the potential to increase fuel economy and reduce daily operating costs. These achievements include 1. Packaging innovations combining 2 silicon carbide inverters. 2. A power module with integrated thermal management for engine coolant integration. 3. Gate driver design to enable high temperature operation. 4. Advanced protection features necessary for fast switching silicon carbide power devices. 5. Very high converter efficiency at full load and significantly improved efficiency at partial load. 6. Clamp-on current sensor technology for manufacturing simplifications and hotspot temperature elimination. 7. Active and effective cooling to prevent heat spread from the electric motor to the converter. 8. Novel packaging of optimal size DC bus capacitor module to prevent capacitor overheating. The market-ready Expect silicon carbide technology can enable increased fuel economy, improved inverter and motor assembly without requiring power cables and power connectors, improved integration of electric drivetrain in heavy-duty vehicles, simplified vehicle architecture, eliminated dedicated cooling pack for inverter, and reduced daily operating costs due to increased fuel economy.
So one of the slide talked about, or one of the picture that you saw in the video talked about partial load efficiency. So in on-road vehicle, depending upon, like I'm driving the hybrid, right? So my car has a power mode, eco mode, and also the charging mode. So essentially what happens, most of the time vehicle operates in eco mode. That means you are engine is putting about 30% load. Our overall powertrain is putting 30%. So you don't need to be super efficient at full load, because majority of the time, unless you are hill climbing, you are operating into the full power, right? So partial load efficiency is extremely important. So in silicon carbide technology, partial load efficiency dropped down from 90 to as less as 68%. In silicon carbide, it doesn't decline less than 90%. So it's very, very 99% efficient inverter, and it only lose at 10% at 30%, 40% load, and silicon IGBT. So for battery powered vehicle, this is very, very good technology. That's why you see all these automakers, Tesla and everybody is working on silicon carbide inverter technology. That's one of the reason Deere is after. So then we had this PD550 inverter that went into our production 644 loader. We hosted DOE and put this our Gen 1 inverter, needed to modify the cabinet. Actually, inverter is here right there, but you climb in the cab, so but it requires much less space, and Gen 2 is even much smaller than that. So what are the lessons we learned? IGBT mindset, like traditional mindset, doesn't work. You need to go out and exploit the unique property of the material, wide bandgap silicon carbide material properties that I mentioned earlier, and you need to pay attention to our voltage, cable, connector, all that. And one of the experience that you talk to inverter expert, they would tell connector, that's one of the things that fail. So you need to pay attention to these things that low hanging fruits that people often ignore. And then you need to pay attention to common mode voltage, current, EMI, EMC. And when we did good packaging, our Gen 2 inverter has ran very low over voltage. So like when you are turning up device and device turns up with the transient like this, it's very, very bad for health of the motor bearing, motor insulation, all that. So this technology, nice packaging, has allowed us to cancel these effects, and also so at the EMI, EMC issue. So then we thought, okay, let's qualify it to over a wide range ambient, wide range coolant temperature. So we sweep the ambient condition, gone up to 75-degree ambient. And once we ran coolant more than 90 degrees C, we couldn't operate in more than 60 kilowatt continuous. We wanted to operate 150 kilowatt continuous, 200 kilowatt peak power. We couldn't do it. And the reason is that because not the power module was heating up. There was some component were heating up. So heat rises, usually 95% plus heat produced by power module taken by coolant system, but 5%, that's what heats the air inside the box. So if you do thermal management, thermal treatment, once we did that, we were able to run 55 ambient, 115 degrees C coolant continuously flowing through the inverter, no issue whatsoever. And the beauty is that the capacitor was 85 degrees C technology, lot of low voltage electronics was 85, but this is 175 degrees C technology. So packaging and thermal management has allowed us to marry the technology of different temperature. So then innovation by C solutions. So when I started this project, I began counting, let's do those, count those C. So can we reduce the capacitor? We did. We reduced the capacitor size by 5 times, cost by 10 times. We gone coolant from 70 degree coolant to 115. So we can simplify the vehicle architecture. Connector was simplified. Then the overall the size of the inverter went down, and we cut down a lot of material intensity in the product went down. We applied advanced control. We used coreless current sensor. In current sensor, actually, the heating happens because of the switching frequency, because of the fundamental frequency, and because of the fundamental value of the current. So magnetic core heats up in the sensor, so we eliminated core itself and ran the coreless current sensor. A lot of treatment needed to do, but we were successful. We are in process of eliminating cable. We cut down a lot of copper. And of course, at system level, we are competitive as compared to traditional silicon IGBT technology. And as you know, success feeds success. So, I'm pretty much, I'll know an expert in DOE circles. I get called to a lot of advisory meetings and planning, road mapping and all that. So we acquired one more grant in 2021. It's nearly $4 million program with Deere match, nearly $2.75 million coming from government. And we would be putting diesel electric hybrid powertrain. Means we would be putting battery along with the diesel engine to downside the engine and make vehicle more productive and performance. So a lot of work on battery control, power management, and things like that. And Deere is aspiring to put a lot of battery powered vehicle. It's a known knowledge. You can look at a public release on the Deere. In fact, we bought battery company. That's a public knowledge. In fact, yesterday there was a LinkedIn release that Deere has did groundbreaking for a battery factory in North Carolina. So we would be building battery in the US, but this project is about developing the charger. So today we take fuel to the vehicle. Tomorrow we would take the charge to the vehicle. So this is mobile fast charger. So this is another project funded by government. So currently I'm working on nearly $7 million government program. There are two other programs that I'm indirectly working with our collaborator. So that, and then I would summarize. So silicon carbide power is real. You need to find unique application. You cannot put everywhere. You need to see where silicon IGBT technology cannot enable certain form function. That's where silicon carbide can go in. Even if component level cost is not met, you can do system level cost. System level cost, neutral performance superior solution can be designed, and you need to do innovation. And we applied innovation by 9C solution. So that's brought us from here to here. So I would like to acknowledge US DOE because there's a lot of my work that I did since 2014 was funded by government through Power America and National Renewable Energy that was mentioned in the video that I had. This is a group of scientists, very, very, very smart on thermomechanical stress analysis. In our Gen 0 inverter has a 12 die, MOSFET die per MOSFET position. Our Gen 2 inverter had 5 die. So this work was enabled by these guys. They have done a lot of CFD simulation, thermal simulation, thermomechanical stress simulation. So their contribution was extremely important. And of course, Deere management, Deere team, my team in Deere, I like to acknowledge them for the work I presented today. With this, I would be happy to answer any question you have.
Thank you so much, Dr. Singh. I think it's fascinating to hear this developments that you've carried out in a short time that had huge impact, in the country, in the world. Anyway, the questions we have is, the first question we have is, and participants can put their Q&A, the questions on the Q&A or the chat, so we can read those questions. The first question is exact emerge driven by a human or controlled using a remote?
The tractor is driven by human today, but we have autonomous tractor, right? So this summer or last summer, some autonomous tractor drove, and you can have a YouTube videos on the YouTube channel. So it's all about path planning by that autonomous tractor. But today, exact emerge, it is a planter. It's equipment that attaches with the tractor. It has to have a drawbar, right? So it is currently being driven by human, by the operator of the vehicle, but it's good to go with autonomous tractor as well.
Great. The next question is, Deere's EV tractor lineup, like the 7R, 8R, and 9R series, looks interesting. What difficulties does Deere and company face to make sure that the deployed units are safe in terms of cybersecurity as electrifying tractors expands the attack surface?
Yeah, so we have a team. That IT team looks into the cybersecurity aspect of it. We have cybersecurity hardware and all that, and safety feature are being developed. So.
Okay. The next question is, can you describe the capacitor technology?
So capacitor was polypropylene film capacitor. So these are good up to 85 degrees C, hot spot, unless you don't want to derate. So we kept temperature, but these are polypropylene film capacitor versus aluminum electrolytic capacitor that was used in PD550 inverter.
Great. And could you talk about the EMI and EMF improvements, what you observed?
Yeah, so essentially in silicon carbide inverter, currently the production inverter is running EMI, EMC qualification, all that. But we took our Gen 1 inverter and ran through EMC, EMI testing, which we have huge facility in ISG Fargo, and the signature were similar to that what we had in first generation PD400. So treatment would be that you want to have very nice shielding between power stage and the control stage. You need to apply traditional differential mode signaling techniques and all that, and shielding aspect of it, and making sure your packaging, you don't put any pointed object in the box and things like that, and then a nice treatment of how you are terminating inverter with the motor, all that. Our overall comprehensive approach helps you to qualify, become CISPR compliance for EMCMI standpoint.
When can I get 100 horsepower electric for my farm? How many years out are they?
So we have some program working on, right? So it would be public knowledge pretty soon. You would hear, and I think 5,000 series or 500 series or 5,000 series, I don't remember exactly, but the number start with, like the person mentioned, 7R, 8R and all that. R is actually the highest, like what you call how many features you have. So we have 5,000 series, some battery powered coming soon, but those are probably not high 100 horsepower. But indeed, we are working on such technology. As you know, the issue is that 1 liter diesel has a 275 kilowatt hour energy. So you can imagine that replacing liquid fuel with chemical battery is not that easy, right? So since these vehicles consume a lot of fuel, so definitely up to certain power, these can become battery powered, and other power higher than that, somewhat less carbon intense fuel type engine would be putting vehicle power.
What are the current challenges, for off-road vehicles that are still need to be addressed? What are you? We have a lot of students who are listening to this call too. So, what advice do you have, and anything that you can shed in terms of the opportunity space for someone to work on something?
Yeah, definitely. I would say if somebody looking John Deere, right, you come with a good problem solving skills, communication skills, teamwork, and then we train you, we Deereize you, right, on a John Deere. Usually what I have seen in ISG Fargo organization, because that most of our hiring is through internship, and we have EDP program, which is engineering development program. So we rotate person over 2 years with different functions, job functions, and hope that they would find their home. So a lot of EDP program, engineering development program, EDP. And then our intern, right? If you are junior year interning with us, do good job, expect probably that would turn into full-time employment. Electrification is space. We are hiring people with advanced degree. We got nature of the work and all that. So look for our internship opportunity, and there are some open positions. Deere continuously puts out, jobs out there. Regarding the difficulty, there are many actually, right? Our customer are asking always, what is next? What is the next best thing? So that is actually enabling us innovation. So like, for example, this battery powered, right? Our engine is good design for 15,000 hours. Can I say same thing that I designed battery on the vehicle? It would last 15,000 hours, which is about 6.5 to 8 years, depending, right? And I'm talking about tractor, the turf care vehicle like lawnmower, all that, those maybe not, because those are seasonal uses and all that. Those may be good for 3,000 to 5,000 hours and things like that. So battery would be big, challenge, and that's why we bought battery company, right? Working with some people, the smartest people in the world. Power electronics, it's a very difficult to find power trans engineer these days in US, because everybody's working on battery powered vehicles, solar energy, renewable energy, charging technology and all that thing, right?
Speaking of renewable energy, there is a question related to this. I think if reducing the CO2 emission is the goal for electrifying tractors, where do you see the possibility of incorporating renewable energy sources for this purpose?
Yeah, so I'm a battery powered vehicle. If you look at overall the life cycle or material flow analysis, story not that green as it's perceived, right? So you need to reduce carbon footprint in the overall manufacturing. Then you need to have a credible path for battery recycling. Let's say that's all said and done, right? Let's imagine I achieved zero carbon intensity, right, in battery powered. But then I need to charge these battery with renewable energy, right? So can solar, wind, or hydro, or nuclear power use versus coal fire power plant based electricity charging these battery, right? So I think off-road vehicle, one of the challenge that I perceive would be charger. Like on-road charger may be available, Tesla charger or a charger, but about a year ago there was a survey carried out on the charger, and satisfaction is only 60%. Means 40% people did not get the service they expected, which is not good, right? You cannot expect that a low satisfaction. So I can imagine that charging ecosystem would be quite challenging. These charger are solar powered, wind powered. Can this be done, right? It all depends on economy, right? Can who is going to bite the bullet kind of thing, right? So we are working on charger, but electricity that comes to the charger is not their domain, or at least right now, I would say.
Thank you so much. I think that's all we have questions. I think I appreciate sincerely for your time today. I think it's been a pleasure to having you and listening to your experience and all the great things. Thank you, Dr. Singh, and that concludes the webinar for today.
Thanks for having me, and thanks for listening. It was a great experience for me.
Please visit UND.
I would come. Thank you.
Thank you.
Yeah. Bye all.
Bye.
And for all.